So we as engineers work within this world, and we implement cool products, work probably within enterprises. And the main component of all of these systems, products, applications is e-commerce. Different products and different companies decide to use a common product set to build e-commerce platforms. For example, it can be Magento. But for some of them, it is a personal matter to use implemented by own e-commerce platform. So this talk will be about how to build e-commerce platform. We will go through some problems and challenges while implementing this e-commerce platform. We'll go also about some challenge example, and we'll understand how to improve. So let's start first with building e-commerce platform principles. First of all, to build a platform, we need to understand what is the goal, right? So to be able to build that goal, we need to understand what is North Star metric. So the North Star metric is the single measure that can show us long-term success of a company. What are characteristics of this North Star metric? So first of all, it should be leading to revenue, because this is our goal, right? Next thing, it should reflect customer value. So product is built for customers, and it should bring the value for them. And also, it should be defined in that way that we can measure progress. So that means that each engineer, each worker can understand how his work implies this metric, how he can help to achieve this goal, right? Here are some of examples. For example, metric which sounds like the number of customers purchasing each week. It is for selling the product, right? Number of weekly customers completing their first order, the same. Value of daily purchases, customer lifetime value, and there are a lot of other examples. You can search through internet and see North Star metrics of global companies. For example, in traveler business, a metric can be number of bookings. For Uber, it can be number of drives. For Slack, it can be number of active users, etc., etc. So first step is done. We have defined a North Star metric for product. But what is a North Star metric for e-commerce, for platform? Here I would encourage you to think for a second. If we define and build a platform, what it can be. The platform, it is something that built for other users, for other developers. So we represent services which are used by another services, right? So probably the best example here would be probably API first approach. Okay, now let's look into design of e-commerce platform. So this is a basic picture which represents that we have different clients which call e-commerce from UI perspective. There are mobile clients. There can be also partners which represent different other products. And we can also integrate with different third-party services like payment providers, right? To identify the main components of e-commerce, there are 5 main points. There can be a bit more of them, but those are exactly what we need. So there are checkout, there are pricing, there are payments and fraud, order management system, partner onboarding. This component exists if you need to integrate with new partner, it should know about how the system works and what he can use, right? And all these domains are related on e-commerce core, which acts in parallel with the core product components, right? So best suitable case what to use to build e-commerce platform is a domain-driven design. And each domain can represent a set of services which are owned by separate teams. Okay, so next, When we choose domain-driven design, next what we need to do is to understand build principles and probably choose some strategies and execute patterns, right? So e-commerce platform is something where complex flows of payments are being executed. And here the most challenge is distributed transactions. To implement distributed transactions, there are some challenges. So for example, if you choose domain-driven design and microservices architecture as a middle layer between monolith and serverless or cloud, so we use microservices, and the favorite pattern to implement microservices is database per service. The main idea is when microservice executes single responsibility, we need to store some data, and here probably database per service can be a case. It helps to encapsulate the domain data, right, and not intersect between other domains. Good thing that this service can scale on its own, and it is insulated from other domains and their failures. But here is one drawback. We need, in terms of distributed transaction, to have data consistency between storages, right? And that is a challenge. Next thing that we can use is two-phase commit. It requires all participants to commit a rollback. That means that some main service will ask each time, each component, are you prepared to commit? Yes, once yes, we do commit. But here are some drawbacks. If we use NoSQL databases or message brokering, they do not support this model. So to phase commit needs some transaction management. For example, in Java, it can be Jakarta Transaction API. It requires atomicity of transactions. So for example, there can be used web services atomic transaction and some principles of extended architecture. And also, in terms of parallelization, there can be inter-process communications where we can store data between separate share data between separate processes, right? But there is one drawback. This parallel communications needs all services to be available. If one of services is out, then it reduces overall system availability. So that is not the case. So what to do? Probably the best idea here is to use SAGA pattern. So SAGA pattern is based on orchestration and choreography coordination. And in terms of complex flows, complex payment flows, where it goes through different domains and different services, it allows us to make local transactions and emit events in other components while transaction is ready. If there is a failure, then there is a fallback, which is compensation transaction, right? What are the drawbacks of SAGA pattern? So this is a sequential flow. And if component 10, let's say, fails the transaction, it means that there should be compensation for all previous steps. So it emits the reverse transaction N, which in its turn emits all the transactions up to the first one to go to the end. And again, coordination of SAGA pattern, we can use orchestration where we can implement synchronous and asynchronous interconnection between services, or we can use choreography, which is best suitable for eventing model. I don't want to stop here in details because you can see yesterday's great talk of Meta, who has shown a great example of how orchestration and choreography can work in with cloud example case. Yeah. So what are the alternatives? SAGA pattern is based on transactions, and more event-driven approach is CQRS and event sourcing. So CQRS helps us to split transactions for query and request, and split operations for mutable and immutable. Mutable operations are updated, delete, and immutable are create and read. CQRS approach also connected with event sourcing. It helps when you need, for example, to save state or history changes according to the business entity. And also, it helps to read some optimization in performance, scalability, and security. The last pattern, it is listen to yourself. It helps to implement parallel pipelines model. For example, it can be implemented when service pushes event into some event broker, and this service also listens to this broker. Why? Because if we send event to execute another actions, we listen to this action to use the outcomes in another pipeline. The drawback here of parallel pipelines is you can't use them in entire system. You can use it in small parts, or basically some extracted components. Because again, it leads to system entire availability. Okay, so now we think about scalability of our services and trade-off between consistency. It should be strong or it should be eventual. And there are some strategies that we can use. Of course, based on complexity of e-commerce system or based on complexity of flows, we need to choose some strategy, right? And choosing between scalability or consistency, we see that modular monolith, for example, and two-phase commit are something which is strong, consistent, but lowly scalable. Parallel pipelines has its drawback, but it can be coordinated or mixed with orchestration or choreography. So if you need to choose REST approach, you will probably choose SAGA and orchestration. If you need some choreography, probably case here is CQRS and event sourcing. For CQRS and event sourcing, I will refer to past talk, which perfectly covers this topic. Okay, let's go next. Once we have defined our strategy and we have defined patterns, we should not forget about reliability. So e-commerce, talking about e-commerce, we can highlight three main points. First of all, we build it for users, and users are main ones who pay, right? So our system might be reliable. Talking about quality attributes, it should be also performant and secure. And looking at the complexity of e-commerce system, there are patterns which help to organize reliability. It is retry and circuit breaker. Retry usually is used where the load between services is not much high, and you just need to call some service several times. But circuit breaker is bestly suitable when you, for example, do a lot of requests on external systems, because it helps to like set a lot of configuration around requesting. And how to monitor reliability. There is another pattern which is health endpoint monitoring. It is represented by web frameworks which expose metrics on endpoint, and it helps external systems like Datadog, Grafana, Kibana, etc. to gather those metrics and represents as charts or even dashboards. Let's go next. Once we have identified how to build this system, so we know right now the goal, we know right now strategy, we know right now some patterns which to use. Let's define some common problems and challenges working within e-commerce platform. So there can be a case when you pay for some product or service, and there are different approaches how you can do that. For example, instant payment. When you choose product and you do payment immediately. There can be also a case when you partially pay for product. For example, if you want to order some delayed product or delayed service, you can pay, let's say, one half now and one half in some future, right? And there can be a case where some partners or integrated brands can use your system, or you can use their system. So the flows are different and they come through different domains, which can be seen on the picture on the right. But here we have some challenges. So for example, there are flows or features which touch different domains, right? So in this case, we step out of the domain scope as team that owns this flow, which leads to what? It leads to contributing to other services, because if you need to improve this flow or add some additional feature or configure it, you may need uh, to work within services which are owned by others, right? What it leads to, you are not the owner of a repository or service, right? So you need to ask someone to review these changes, to test these changes, and so on. So this means crossing the boundaries and responsibilities. And also, there are cases when you have shared ownership services. So it is a single service which is a point of intersection, for example, of different domains, where responsibility of one team can end and responsibility of another team can start. What this can cause? When some failure happens, you have an incident, right? So in incident management chain, there are teams which are involved, not single team, but a lot of teams. And if we scale this to all our domains, that means we need to identify where is the error, and to be able to identify that fast, there is a possible problem when there are a lot of teams might be in the incident involved, right? So that is a challenge. Let's go next. So working in enterprise and e-commerce platform with high complexity looks very similar to an enterprise style of work, right? So legacy flows is something that is concerning developers and engineers. Why they're used? So often they're used as a fallback mechanism. If we identify some new flows, we implement new features, we implement new logic, we still can use legacy flow as a fallback because it still can bring the money. But in other cases, it may be actually not needed. And sorry, it may, it may not be needed, but it is still used as it still brings the money. Or there are cases when you have old customers, old clients, which use this flow still. Another drawback is that each legacy flow requires constant support and adoptions for business changes. So we do not implement new features, but we still maintain it. And there are some minor fixes which needs to be done to legacy flows. It has an additional functional complexity for entire system. And we still not need those we not need these legacy flows, but they are still used. And in terms of KISS principle or Yagni principle, we break them. Also, legacy flows are often badly described. Why this happens? Because nobody cares about legacy, right? So it's maintained, and if I need to do some change, I just do it, but it is legacy. I don't care about it too much. So I don't update documentation, or somebody can actually, but it can be outdated very soon. Also, having the fact that it can be badly described, it means that we rely on knowledge keepers, and if there is a rotation of people who own this flow, then we need to rely at least on some knowledge keepers, and a bad thing when we don't have them. And also legacy flows often rely on legacy code, which is a part of next topic. So legacy code is something that is working, but it still exists. We all want to work with newer set of technologies, but legacy code is something that is frustrating nowadays, but it still exists and it still brings the money. The legacy code has lots of dependencies and limitations. because of standards, because of adoptions, and there are a lot of examples uh, which we can name here. The legacy code is hardly adoptable, and each product has its standard for architecture or technology set, which is continuously improving, right? And legacy code and legacy flows are hardly adoptable with this architecture because the most thing here is support. Of course, that brings another complexity that it is hard to integrate with those parts which own the legacy code. And also, there can be a case when pipelines to release are outdated. New pipelines for release are based on new technology set and new standards, but pipelines for legacy code are not supported anymore. That introduces the complexity of having this legacy code. Also, it is affected by technology contracts, so there are limitations. You can't, for example, switch simply one technology to another technology or refactor it because it can break some sensitive flows and it will cause in its turn loss of money. That's why it trails behind the tendencies, right? So company products goes fast into the future, but legacy code still trails behind. And again, comparing to legacy flows, this code is not well documented. So there are a lack of Java docs, a lack of any Confluence or wiki documentation around it, or there are cases when, for example, there are some documentation around this code, and there are a lot of versions of it. So, for example, there are a new developer who works with this code. He works with this scope and tries to build his own Confluence page to describe how to work with it, right? How it is executed and all the information around it. But it becomes outdated soon, and the next developer which is coming is also trying to deal with this code, and there are some changes that could be potentially done, and he produces a new version of documentation. So you can see a case when you look for some question for an answers of your question, and you will get a lot of documentation around the same, but this documentation is contradicting. That is a bad thing. And also, last part probably of main problems, it is integration. So once you have a system, once you have a platform, you rely on API and core entities of product. Yeah, and each new integration should connect with each other, like sending the same versions of entities, right? So probably there will be a case when you need to adopt to be able to communicate with a single type of core entities. Next one, there are conflicts and intersects with legacy parts of code, right? So that adds an additional complexity. Also, when you integrate a new component, it may require, but may not in some cases, technology adoption from both sides. It is good when you interact by some contract, but there can be a case when you need technology adoptions from both sides. Also, when you integrate with a new component, a new service, it is a new participant in distributed transactions. This is a problem in terms of incident chain, because if you have a problem, you need to identify the place in type flow, and this is a new element in this chain. Okay, let's represent how this integration problem can be visualized. So let's say we have an ownership service and we have a flow which goes through this service, right? And we have a line which splits responsibility of domain 1 and domain 2. At some moment of time, it happens failure, and there is an incident. One side decides that there is an error based on monitoring tools or whatever else. And it signalizes that there are some errors happening in downstream. So downstream needs to look at it and, of course, fix it because there are no other participants. What happens if we have integrated component? And the worst case when integrated component, knowing nothing about shared ownership service, where it knows nothing about what's inside shared ownership service and knows nothing about the flow. And there is an error on its side. Who need to take a look on that error and fix it? Of course, both sides. So that is the representation why it is an additional participant in incident chain. Okay, right now let's look into the example of challenge, which can be a case in e-commerce. So it is a deprecation of financial flow. Let's imagine the case when you have a product and you have an e-commerce component of it which works perfectly, and at some moment of time you integrate with another system which becomes parent. And that parent system needs to monitor everything, monitor orders, monitor payments, etc., etc. So it becomes a system of record. And you need to redirect payment flows to it, but you still want to monitor on your side what happens, right? So you have your own order management system, and of course, on parent side, there is an order management system too, but all the payments must go through it. So the business need here is to migrate all the payments flow, but there is one drawback. For example, for delayed payments, when you pay partially, there can be customers which used some business flows, right? And in terms of consistency and data loss, you need to maintain at least part of flow, which has become legacy. So you can't deprecate it at all, which means you need to deprecate some of logical parts, but it still should be used until all the customers which did payments in past will execute their final payment in future. And of course, deadlines are something which introduces another complexity. So this example I had in real life, and let's see the presentation, how it is, how it can be shown visually. So we have different domains. We have a number of services for each domain, right? So for internal system, there were some flows with services interaction. And at some moment of time, you need to redirect flow to external system, right? So we execute some logic. How to deprecate here? You need to deprecate some lines, parts of this logical flow. Okay, so starting about execution, we have next prerequisites. Usually it happens when prod and non-prod environment are inconsistent. So you can't test anything on prod data, and there are not fully matching examples on test or stage environment, right? So there is no guarantee if you will execute it on test or stage first, there is a 100% success guarantee, right? Real-time traffic happens only on production, not on testing stage. So testing stage exists only for some testing purposes, test execution, etc. Okay, next, statistical data. It can be extracted only for prod because having the live traffic, we have a lot of data, but only testing environment, we don't have much data, and we cannot guarantee that our implementation of deprecation scenario will be working. Of course, there is a lack of test data and testing for some of critical points. It can be a case because in such huge systems, test coverage is not something that is reachable in high percent. Okay, so we have lack of test data, and we can think as one of strategies. Okay, we should start with refactoring, and each refactoring starts with implementing tests. But implementing these tests requires understanding of business domain, understanding of business flow, and it will take much time to implement it, and then probably somehow try to refactor it. So it is not the case when you have a tight deadlines. Also, not much documentation, or vice versa, contradicting documentation, right? It is also the case we have discussed. So, what to do? It is also an option when you try to implement partially this logic, right? But if something goes wrong, then you'll need to revert this change. And in terms of incident management, if it is built very badly, it will mean that time to investigate issue where it happened will will be probably huge, and it will lead to loss of cost. Of course, there is a huge risk to fail orders, and that is not the case. What to do? You decide to ask if there is any person who can help, at least with understanding how this flows goes, what are the risks, what are the main critical points. But the most knowledge keepers have left because of different reasons, or it is rotation, or it is like switching to other domain. So you don't have any person to help you. Looks like a huge challenge, but how to resolve it? So first of all, you need to understand the flow, how to work with such complex examples. First of all, you need to identify. You need to identify the scope. Within this scope, you need to identify all participating components, all domains, and all services which are under those domains. You need to figure out all the teams which own services where this flow goes, right? So having understanding of scope, you need to do some decomposition. You need to define all points of integration and all decision points within services. And there is a recommendation to have a visual representation of flow that is passing those points, right? So we had this on one of previous slides, an example of it. Okay, once we have identified everything, we're ready to build a plan. So what is the strategy to execute a plan for this deprecation? We have we have critical points, we have points of integrations. So what we can do is cover all defined points with feature flags. So here we apply strategy of feature flags development, and it helps to control everything. If you turn off the flag, there can be a risk that at some point of time there will be a failure and you will not know which flag is exactly causing this issue, because errors are monitored, and there is an alert which happens after some time. For example, 15 minutes or 20 minutes or 30 minutes, it depends on how your monitoring tools are set up. So even 15 minutes can lead to huge cost loss, right? So you need to eliminate risks, and that's why you need some control point for all these flags, and it is a main flag. If you turn it off, then the logic that comes through point control flags will not be executed. Monitoring, of course, when you define some logic which will be turned off or on, you need to improve your logs. You need to bind them to monitoring tools. You need to stop dashboards. You need to choose correct thresholds and bind them to alerts. Okay, if you have done all of this, you need to prepare. So you need to wait some data to be collected because you have introduced new logs. And once you have enough, there is a time to execute the strategy. So what you do, you start to switch off these flags starting from downstream services, right? And go to the upstream services. If you have something unpredictable, you always have a main control flag, and you can always turn it off, and the logic will be executed as it was before flags, as a regional, right? So this is kind of compensation in case of unpredicted failures. And once you have reached what you want, entire flow works as expected. You don't have any components or flow lines that you don't need. Don't forget to clean the rubbish. Rubbish, I mean flags and logic which is not needed anymore. Because feature flag development, it's something that can help you to control the logic immediately without spending time on root cause analysis or redeploy or rollback, etc., etc. But if you have a lot of flags, it can cause issues with the number of them, because at some moment of time you'll not understand why this flag is needed. So don't forget to clean everything after you executed this flow. Here is a visual representation. So here, red lines, red arrows are something in this flow which we don't need to use. And there are integration points, and there are critical decision points. So we cover all of them with flags, right? And once we turn them off, all the flags are being controlled by a central control flag. And there is a prototype of logic which can be executed to help reach our goal. So once you turn off the flag, the default or fallback strategy will be executed. If you turn off the main control flag, then original logic will be executed. So this is an example how simply complex problem can be resolved. Okay. Having this example, having an understanding of how to build e-commerce platform, what are the recommendations, how to improve existing e-commerce platform. So first of all, when you design it, choose clear goals, right? Don't forget about North Star metrics. Choose the best strategy and patterns to design. Next one. Please, this is a huge recommendation from myself. Follow the quality standards. For e-commerce platform, there are probably two main standards. First one is ISO 25010, which describes top 3 necessary quality attributes for e-commerce platform. It is reliability, which includes availability and fault tolerance. It is performance, and it is security. Also, don't forget to update your documentation. Next one, you need monitoring to reach reliability, quality of reliability. So set up your monitoring systems, improve alerting, don't hesitate to revise strategies, monitor statistics based on some period of time. Let it be 3 months, let it be 1/2 of a year, any suitable time range. But you need to improve that, because at one point of time when somebody will implement new feature, or new flow, you can be affected by incident management, because if you don't revise it, there can be potential root cause plays in what others did. Okay, and also don't forget about logs. Monitoring is something which is split for health monitoring and logs monitoring. Health monitoring tools like Datadog or Grafana can help you to identify which component of chain is failing. But to understand what is an exact failure, you go to the login system and look for exception or error or anything else. So both of them are quite important. Next, process. So monitor statistics often and improve them. And also, there is an incident management process, which you need to have a separate process according to SDLC. So there are retrospectives, there are postmortems, which can help you to understand why this incident has been caused, what we can do to avoid it in future. May we need to raise thresholds or vice versa? Do we need to pay attention for liability? That will really help you. Okay, and last point is development. If you develop within e-commerce, you need to decouple as much as possible because this helps to define clear boundaries, right? And even flows which come through different domains and through shared ownership services, try to avoid them and split between smaller components. That will help to cross the strict boundary between responsibility of one domain and another domain, between one team and another team. Also, adopt refactoring. Refactor as early as possible because at some point of time, there will be a necessity to adopt a newest set of technologies or new product standard. And don't forget about the feature flagging strategy because it helps you to control the logic immediately. That can help you to resolve quite complex issues. Okay, so having all that in mind, there is a question how this knowledge can help me. So e-commerce platform, it is a great example when you can get experience working within an enterprise. Because the more complex e-commerce system is, the more it looks like an enterprise. Here you will have a lot of complex tasks, a lot of complex issues, and having an understanding how they're being processed, you will have a helicopter overview on complex things. You'll learn how to pay attention for quality attributes, also understand how principles and patterns that you choose for interaction within core and users, how they are applicable and which role they play. You also will understand the need and complexity of refactoring engineering strategies. There is a best probably place where you can do that. Also, e-commerce is a component which works with money, right? So you will understand how to deal with risks and apply risk mitigation strategies. Once you work with risks, that helps you to make better decisions. So all of these things are mostly connected not only to hard skills and not only develop you as a coder, right, as a developer, but more like a software engineer, like a professional. So e-commerce is something that can help you to grow professionally in all kinds of areas. Okay, on this point, I would like to stop and thank you for attendance. If there will be any questions, I will be available around. I will wait for you on our soft serve table and will be glad to answer all your questions that you have. Thank you.
Thank you so much for a great speech, and let me invite you to the discussion table to answer some questions from our participants. And dear participants, please do not hesitate and take part in the discussions. Ask your questions to Bogdan.
Of course, thank you very much.